Okay, we're going to look at the relationship between velocity and acceleration and speed now. So the question is the speed increasing or decreasing based on the velocity and acceleration? Okay, so we're going to look at 4 different scenarios. First of all, the first one is, what if the velocity and acceleration were both positive? Okay, so what we're going to do is look at the position graph. So this is time, and S of t is going to be the position of this particle. So if you remember, if I give you position graph, if that's like f of x, remember the velocity is really the first derivative of the position graph, and then acceleration is going to be the second derivative of the position graph. So if we're graphing the position graph, and I tell you that the velocity is positive, that's really your first derivative. So that means that I know that the original function is going to be an increasing graph. And if I tell you that the acceleration is positive, that's really your second derivative. So that means the original graph is concave up. So I need an increasing concave up graph. So something along these lines. Now, what can we say about the speed? So one thing to know about speed is that speed is the absolute value of velocity. So when we talk about velocity of a car, if we say it's positive 55 miles per hour, we can say it's going forward. If it's negative 55, we can say it's going backwards. But if I ask you for the speed, it would always be just 55, regardless of whether it's going forward or backward. So it's just the absolute value. So if I want to look at just the absolute value, in this case, the velocity or the speed is always positive. Notice that, again, I don't know exactly what these numbers are, but I can say that these slopes are getting bigger. So in this scenario, the speed is increasing. Okay, let's take a look at the other 3 scenarios and see what happens. So same thing. I'm going to graph the position graph and see what's happening to the speed. If the velocity is negative, that means that the position graph is decreasing. If acceleration is negative, that's the second derivative. That means the position graph is concave down. So I need a decreasing concave down graph. So it's going to look something like this. Now let's look at the speed of this. So again, speed is absolute value of velocity. So that would just be the absolute value of the slope of this graph. So I'm going to just make up some numbers. So let's say this is -1. This is still negative, but notice it's getting more negative. But if I take the absolute value of these numbers, notice these numbers are getting bigger. So the speed here is also increasing, because remember, speed is the absolute value of the velocity. Okay, let's take a look at the last 2 scenarios. If velocity is negative, that means I want a decreasing curve. Acceleration positive, second derivative, so I need concave up. So this graph looks something like this. So let's look at our speed, or the slope of this graph. So notice, again, I'm just make up some numbers. Let's say this is -3. This would be like something like -1. This would be -1/2. But the absolute value of these numbers are getting smaller, so I would say speed is decreasing. Last one, velocity is positive, so that means we need a increasing graph. Acceleration, second derivative negative, so that means we need concave down. So increasing concave down looks something like this. Oops. And again, let's start looking at the speed. Okay, so let's make up some numbers. So this is a positive number. If this is like 3, this is getting flatter. So let's say this is 1/2, this is 1/4. Notice these numbers, the absolute value is getting smaller. So I would say the speed here is decreasing. Okay, what you'll notice is in the 2 scenarios where the speed is increasing, notice the sign of the velocity and the acceleration are the same. So here, they were both positive. Here, they were both negative. In the scenarios, the 2 bottom ones where the speed is decreasing, notice that the sign of the velocity and the acceleration are different. So if the signs of the velocity and acceleration are the same, then we're going to say speed is always increasing. And if those signs are different, then the speed is always decreasing.